show you how to find the area using the Simpsons rule. In the previous video, we focused on the prismoidal formula. The prismoidal formula gives us the area under a curve that is a parabola, or the approximate area under a curve that is assumed to be a parabola if we know or can find the coordinates of 3 equally spaced points on the curve. When there are more than 3 points on the curve, we apply the prismoidal formula to each group of 3 in turn, and this gives rise to the Simpsons rule, which is summarized below, where the area of a function between a and b, the bounds, is equal to roughly the area of h over 3, where h represents, and this is the complicated part, notice that in our question, they give us data points all the way from 0 to 10, and they're equally spaced by intervals of 1. So in our case, h would equal to 1. But sometimes you're asked to find the area of a function between, let's say, 0 to 10. They don't give you the amount of intervals. So in that case, what you would do is you take your upper bound of 10 and subtract it from your lower bound, and then divide it by the number of observations that you wish to choose. So let's say that you want to divide it equally into 6 observations. So you take 10 minus 0 and then divide by 6, and then that's what you would find your points at those intervals. But in our case, it's 1. Notice that it jumps from 1 at each observation. And then you take your h and divide it by 3, multiplied by, and this might be confusing, this notation to you, but it's really not that difficult. What this actually means, f at x subscript 0, is simply what we had in the previous lessons, where we had y subscript 0, 4 times y subscript 1, and so on. That being said, the question reads, a curve passes through the following data points, shown in this table. Find the approximate area under the curve using the Simpsons rule. As mentioned earlier, h here is equal to 1, so we don't have to worry about that. And the area is approximately 1 over 3 times, and this is where we have to do some arithmetic. We have 4.02, this thing, plus 4 times this next observation, 5.23, plus 2 times 5.66, and this is the interesting part about this. It goes back to 4 and keeps going back and forth from 4 and 2. 4 times this next one, 6.05, plus 2 times 5.08, plus, now we have 4 again, 5.62, plus 2 times 5.53, plus 4 times 5.71, plus 2 times 6.32, plus 4 times 7.55, and this is the interesting part here. In our last observation, take a look at the formula. We have 4 times f at x subscript n minus 1. So this means our second last y observation plus your final observation without multiplying it to anything else. So we have plus 8.91. Also, one thing that I forgot to mention is that you should pick an n value if you've not given a table like this that is even. Now we'll calculate this using our calculator, and if you do it correctly on your calculator, I don't want to go through all of this, it'll take a while, you should end up with exactly 60.1 units squared, and that's an approximate area for this curve. And there you have it. That is how to use the Simpsons rule to find the approximate area.